Good afternoon, everyone. So I welcome you on behalf of Ishre Ahmedabad chapter, and this is one of the very good webinar and virtual visit with the help of our all student chapters. I welcome you all: LD College of Engineering student chapter, GIT student chapter, SVBIT student chapter, Gujarat Power student chapter, PDPU student chapter, Silverlock student chapter. I welcome you all on behalf of all this student chapter. And today we have very distinguished speakers, Shri Dilip Sarda sir and Harshal Sarda sir. Harshal Sarda sir is the director at Synergy Agrotech and working as a secretary of Ishre Ahmedabad chapter. He is very active. He worked as a B2B committee member during the REFCOL 2018. Many of you might be interacted with Harshal bhai. And yes, it shows it's houseful program. So now we cannot accommodate anyone. Still, if vacancy is there, you can accommodate. There is a question during the chat. I answer. Uh, and also we have Shri Dilip Sarda sir, who was ME in the year of 1970 from LD College of Engineering, Gujarat University. He is working as a director at Synergy Agrotech. He is dealing in consultancy and manufacturing of ice cream projects, and also life member of ISHRE, fellow member of ASHRE, also fellow member of Indian Dairy Association, and certified energy auditor from BEE. He has more than 45 years of experience in design, planning, execution, and operation maintenance of in various organizations. Also, he was a co-chair of REFCOL 2018. So the baby that started from Ishre Ahmedabad chapter, one of the pioneer role has been played by our Dilip Sharda sir. So now I welcome Harshal bhai first. Harshal bhai, please welcome you.
Okay, thank you, Hardik bhai, and welcome to everyone for this virtual visit of the Synergy Agrotech Private Limited. We start the video. Initially, it is a company profile. Then we see the three or four working machines for the ice cream industries. Is the video audible?
Not yet. If you can start.
Is the video seen? Hardik bhai, can you confirm?
Not yet, Harshal bhai.
Can you see the video?
Harshal bhai, your screen is visible.
Okay.
But then I think it is not.
Professionals.
Yes.
What started as a consultancy with a powerful vision to the company undertakes deep research and continuous improvement, aiming to deliver high-end technology in quality machines. After 2 decades of experience, and Tanzania, and has already done more than 700 successful installations.
1 minute.
Harshal bhai, it was working nice, but now there is some glitch.
Okay, it was working nice. Can you see the screen?
Yes, yes.
Nice, okay?
Screen is okay.
Okay.
Many people requesting to join because of the limit we cannot accommodate, but let's wait. Harshal bhai, if it is there, then can we start the talk of Dilip sir, and later on we can have this, if you permit.
So first we start a lecture, then we go for this.
Yeah,
You
yeah,
want it?
yeah, yeah, yes, Harshal bhai.
Okay, no problem, no problem, no problem.
Okay, thank you, Harshal bhai.
करना पड़ेगा। करना पड़ेगा। ओके, एक मिनट मैं स्क्रीन शेयर कर दूँ।
Yes, perfectly visible. Okay, perfectly okay.
Okay.
Yes, Harshal bhai, perfect.
Good afternoon to all.
Good afternoon, welcome, sir.
Today topic is a very interesting topic, and in Ahmedabad, all love ice cream. Ahmedabad is very well known as the capital of ice cream in India, and you will be surprised to note that maximum consumption per capita of ice cream is in Ahmedabad compared to in India. But we eat the ice cream, but never we thought how it has been made, how the process is complicated. Let me understand that one, and let me understand how our refrigeration knowledge is utilized in making the ice cream. In fact, refrigeration is considered as one of the raw material in the ice cream. And without refrigeration, we cannot think about the ice cream. Let's first understand the way the refrigeration is required. Refrigeration is required for storage of ingredients such as milk, cream, butter, fresh fruit, dry fruit, and unfinished product. Refrigeration also required for cooling of ice cream mix. We'll discuss, friend, all this process in detail. Just I have listed out the way the refrigeration is required. Then aging of the ice cream mix. I will discuss aging. What is aging? Conversion of ice cream mix from liquid to partially frozen ice cream. Then hardening of ice cream, storage of ice cream, distribution of the ice cream, and brine chilling for the stick product. These are the requirements. But before we go on the subject, let me understand what are the ingredients in the ice cream. If you are knowing that ice cream contains around 10% of the fat, 11% of solid not fat, and 15 to 16% sugar. Plus it contains some stabilizer and the emulsifier in the fraction of that one. How this is made, that I will try to explain to you. If you see,
Harshal bhai, हाँ, side ऊपर right click कर दो, એટલે જતું રહેશે. Yeah, done.
Let me just start the process. This is first mixing tank. This is a mixing tank where we put all the ingredients which I explained to you in this. Okay. This is mixing tank. This is a mixing tank where we put all the ingredients, that is a milk or water, milk or water, then the milk powder, butter, sugar, stabilizer, and emulsifier. We do heating of this mix, this ingredient, up to certain temperature. Then it has been processed further through the pump. This is pump through the filter. It will go to the homogenizer. The function of the is to evenly distribute the fat. That means we break the fat from 12, 13 micron to 1 or 2 micron in smaller size. And it operates on, if you see the pressure, it is more than 2000 psi. This machine operate or develop the pressure more than 2000 psi, and it breaks the fat in smaller particle. After breaking the fat, it will go to the chiller because the temperature of the here is very high, 65, 70 degree temperature, and it required to cool all the storage. So we use this chiller. Here the refrigeration, what I want to explain to you in the process, the first, when you design the refrigeration system, you should know the process of the what is the product you want to manufacture of the industry, and then you can calculate exact refrigeration requirement. So here this is the first unit where we require the refrigeration for cooling of the mix from 65, 70 degree to 6 degree or 4 degree. So this is the plate type heat exchanger where we feed the mix from one side, hot mix, and it is coming out cool mix from second side, and it has been cooled by the well water, cooling tower water, and the chill water. You can see here both system is a two-stage cooling. First cooling is done by well water, so we can save the energy, and then it has been further cooling done by the chill water. Then it has been fed to the, this is known as aging vat, where we store the mix. The name of the aging vat is we require to keep the mix for 4 to 6 hours in the tank so that fat will get crystallized, and whatever the stabilizer and emulsifier we have put in that can do the action. Friend, would you like to have everything English, so that I should change both the language? I should use both the language. Okay, there's no. So what we do, we put the mix in this tank. It is jacketed and refrigerated. This is the refrigeration unit of the tank, and it has been jacketed also. And in that, the chill water is circulated, or the refrigerant direct expansion refrigerant has been circulated, and we do the chilling, maintaining the temperature of the mix at the 4 degrees centigrade. So these are the tanks of that. This is the raw milk. Raw mix is available for the making the ice cream. This is raw plain mix available. Raw, not a raw, it's a pasteurized mix. Ice cream is available. Plain ice cream is available for making the ice cream. So from that, it has been transferred to this flavor tank where we add a color and a flavor and mixing. Then it will go to, this is known as a continuous ice cream freezer. It will go to continuous ice cream freezer. We'll discuss this again in the next slide. The function of this one, the liquid is to be converted in the partially frozen ice cream. So here again, second, you can see refrigeration requirement is in this point in plate chiller, then it is requiring aging vat, and then the refrigeration requirement will come in the continuous ice cream freezer for freezing of ice cream. So this is a unit where we require refrigeration from this plus 4 degrees centigrade of liquid to freeze partially, not completely, around -5 to 6 degrees, -5 to -6 degrees centigrade, and make the ice cream. Now this is a fruit and nut feeder. If you want to add a fruit or nut in the ice cream, we can add by using this equipment, and then it will go to blast freezer. Friends, here the ice cream is frozen partially, and outlet temperature may be -5 or 6 degree, where the not total water, what ice cream contains is generally 60 to 65% water contained in the ice cream. It's totally not frozen. Around 40 to 50% or 55% water is all frozen at -5 degree temperature. I will show you one chart where you will find that how much water is frozen at a different temperature. Because freezing point of the water, due to putting the sugar, it will depress. And this is blast freezer where we do the final freezing of the ice cream. That is whatever water quantity unfrozen, that will be again converted in the ice in this point. And from that air blast freezer, it will go to cold room. Now we want to make a stick product like the chocobar or something. We require the brine system of -25 degrees centigrade, and brine, there's a brine chilling in it, and this brine is circulated, and we put a mold, right? We do casting, and that mold is thawing and chocolate coating, and again it will go to blast freezer for final hardening. So this is the process. It is a certainly complicated, but as far as refrigeration engineer concerned, our refrigeration requirement will be here for cooling of the ice cream mix, then aging to maintain the temperature, then freezing of partial freezing the ice cream, then again final freezing of the ice cream, cold room for storage, and brine cooling. Let's go to next. How we prepare the ice cream mix? First, you have to select a good quality of the ingredient. That is good quality of milk, cream, butter, powder, sugar, everything is good quality. It is very important because whatever you put in, same output, same quality output you can get, because we cannot change the quality in that. Another important step are in the mix preparation is the mixing, which I have spent in the tank, and pasteurization. The pasteurization is a process that I will explain again in the next slide. Then homogenization, cooling, and aging. How to put the ingredient? Let me go to process. Place all the liquid ingredient, that is milk, cream, condensed milk, in the vat. Then start heating under constant stirring. Mix all dry ingredients separately, and then add it at 40 to 55 degrees centigrade. Because if we add the dry ingredient in the cool milk at a low temperature, then lump formation may take place. That's why it should be added at slightly higher temperature, more than 40 degrees centigrade, and it should be mixed properly. Now again, I am coming to the process flow diagram, considering it is a batch pasteurization process. What is pasteurization? First, please we understand. You must have heard the pasteurized milk. Generally earlier we used to get the raw milk. Now, what is the milk available in the pouch? It is Amul or the Sunroot or any dairy, that is pasteurized. It is compulsory. It should be pasteurized. Still, today we are getting some raw milk at home. Many persons prefer direct milk, and that is getting it is given by directly from dairy farm. Pasteurization is a process where all pathogen bacteria are killed and killed. That is a process of heating of the liquid and maintain that temperature for certain time, so that all the bacteria will get killed. That is process of pasteurization. So render the mix free from the pathogen bacteria, bring the all ingredient into solution, improve the flavor by removing the raw flavor. If you know that if when we do heating at more than 50-55 degree, that time the flavor will get evaporated, and so odd flavor will get evaporated when we do the pasteurization, improve the keeping quality, and produce more uniform quality product. how we do. This is a pasteurizer. We say it is batch pasteurizer. There are two types of process in pasteurizer. One is known as batch pasteurizer. One is known as continuous pasteurization. There is no HT pasteurizer. That is high temperature, short time. Here the low temperature, but it requires more time to maintain. It is require more time. It is require more time to maintain, kill the bacteria. The temperature to be maintained for the more time to kill the bacteria. So there is batch pasteurizer in a smaller plant where we mix all ingredient, and you can see this is a heating system. This is a heater, hot water generator, which circulated in the jacket and doing the heating of the mix indirectly. The pump is doing the circulation of the hot water, and we are doing the indirect heating of the milk or mix and bringing the temperature whatever we require, at 65 or 70 degree, and then we maintain the temperature 30 minutes, and after that it has been, this valve is open and pump is started. It goes to the filter, to the homogenizer, and then chiller. Here again, I explained already. Here our representation is there, where there is a glycol solution of the chill water, and this is a well water system. It is taking the heat of the mixing. And then after chilling, it will go to the aging vat. Now, this is second type of process, which is known as STST process. Here, the ingredients are mixed earlier in some tank, separate tank, and we try to maintain temperature 55 degree. Then it will go to STST pasteurizer. It's a slightly complicated process, and we do not have today sufficient time to discuss this process in detail. But what are the advantages that it has got? This process will recover part of the heat and recover also the cooling system. So your requirement of the heating will reduce by this process. So your refrigeration requirement will remain same, but heating requirement will change. It will be reduced. That we'll discuss during the calculation. And after that, it will go to homogenizer, and then it will go back again to chilling system. And this is known as the inlet temperature of the mix in this STST pasteurizer. Then it will go to heated by regeneration system. That is, incoming milk is heated by the outgoing milk up to 75 degrees centigrade, and this has been heated 72.5 to 80 degree by hot water, and this has been cooled by again regeneration, because here we have done the heating, so it will be cooled up to 62.5 degree, and it has reduced our load of well water, not the load of the chilling system, because up less than 40 degree cannot be cooled by the chill water, cooling tower water. So the chill water load remains same, but it can reduce the well water load or the cooling tower load, and it can reduce the heating load also. As I explained already, that there are two types of pasteurization process, batch type and batch type process, where we do the heating 65, 70 degree and 30 minutes, and heating and holding them in same bed. STST process, we have seen, it is suitable for the bigger plant, and temperature program is 55 degree inlet temperature, 65 the regeneration temperature, 80 degrees heating temperature, and 40 degree first cooling, and 60. It is held for the 20 seconds. Here you can say save the time. In earlier process, we require to do holding for 30 minutes. Uniform quality, saving the heating due to regeneration possible. Now cooling. Immediately cooling to around 5 degrees centigrade is essential to control the bacteria growth. The cooling of the milk or the mix is essential after completion of the pasteurizing process. And otherwise, again, bacteria will start growing at a lower temperature. Then it is better to do the cooling immediately less than 10 degrees centigrade. Avoid increasing the acidity. Now, the next process was where the refrigeration required is aging. It holds the process mix for the given period Advantage of the edging, why edging is required? Fat gets solidified, the viscosity increase due to the swelling of the stabilizer. Minimum period is 4 hours, longer period gives a better result. Temperature is to maintain at around 5 degrees centigrade. Here, to maintain the temperature, we require a refrigeration system. Now, how to calculate load? That is simple. They are standard formula. Mass into specific into temperature difference. That is the only formula we have to use for the considering load. Now we discuss what is refrigeration required. So this is a formula that only mass into Cp into delta T is requirement. In how much time you want to do cooling, that you divided by that, you will get the cooling load, that is kilocalorie per hour or the kilowatt, whatever system we use, or BTU per hour, whatever system we use, that system can give you the requirement of Q or the cooling load. Let me consider the cooling load. We want to make 1,000 liters of mix pressure temperature 69 degrees centigrade, well water temperature 32 degrees centigrade, pre-cooling of mix by the well water is 40 degrees centigrade, and mixed outlet temperature 6 degrees centigrade. These are the data available from the equipment design. Now we want to calculate what is the cooling load. Now specific heat of the mix is 3.22 kilojoule kilogram 0 degree Kelvin. Friends, you know the 4.18 is the specific heat of the water, but this contains fat also, SNF and sugar. That's why specific heat of the mix is slightly lower than the water. That is 3.22 kilojoule per kg degrees Kelvin. And process time is 60 minutes. So how much time is required? We have considered it is 60 minutes, it can be 30 minutes, it can be 60 minutes also for cooling, because we are calculating cooling load. So here you can see it is 1000 kg, 3.22, 69 minus 40 is 92,800 kilojoule is a load on cooling tower or the well water, my dear friend. It is not a total load because we have gone up to 40 degree, and if you calculate kilowatt, then it's 25.77 kilowatt. We get cooling load, cooling rate, or cooling load for the well water or the cooling tower. Now, by chill water or the glycol solution, what is load? It's the same 1000 kg, 3.22 is the Pacific, and the temperature difference 40 to 6 degree. We are getting 1,09,480 kilojoule total cooling load. And if we convert that in the kilowatt, we get 30.41 kilowatt is the cooling load. So this is a load where it requires for the compressor for removing the heat from the chill water or glycol solution, whatever may be. We require the compressor suitable to remove this much quantity of heat. Friend, if you have any question, you are welcome to raise that at the end of the lecture, end of this our presentation. We'll try to satisfy you whatever the data available with us, and we'll try to say whatever possible to you. Now, if similar process if be done by the STST pressurization, what will the difference in the cooling load? Here you can see that there is no change in the cooling load. It is same 30.41. Only the load here has been reduced. This load has been reduced. Let me see detailing 1000 kg, mixing let 55 degree, pressure 80 degree, the regeneration 70%, and 60% is the process time. So temperature mix at the end of the regeneration 62.5. This is regeneration efficiency. Means 70% heat has been recovered. It's been recovered for the heating of the incoming milk for the pressurization. That is known as regeneration. So here, whatever heat we have recovered, that we have specified. And so intermediate temperature after this 62.5 minus 40. So our mixed cooling load is 72,450 kilojoule. And if make it in kilowatt, it's 20 kilowatt. Earlier, if you see the cooling load, that is 25.77 kilowatt it has been reduced to 20 point something by the HTHC pressure process. But our cooling load on the chill water system or refrigeration system is 30.41 in this system, and in same system you can see there is no change in refrigerant load. Now, how looks edging wet? Edging wet is a simple vessel with a stirrer. This stirrer is a simple vessel, and there is a spray system or the DX system here in the jacket, and the motor is stirring at a slow speed so that the uniform temperature is maintained. So in case if we supply chill water is supplying the jacket, is spray on the outer wall of the inner tank and returning again back to the plant. In case of it is refrigerated, again instead of the chill water, the refrigeration system is connected, condensing unit connected, and then there is a coil, copper coil. This copper coil is brazed or soldered on the outer wall of the tank, and it supplies the cooling effect to the mix and try to maintain the temperature at +4 degrees centigrade. What is required? This is the edging wet simple structure. How to calculate the load? It is very, I can say, purely empirical judgment. There is nothing like, there is some empirical judgment, and there is nothing like that we can calculate by some theoretical formula. But here we try to do something systematic way. What is the tank size, how the insulation is done, that 100%, 100 mm EPS, responded polystyrene insulation done, or 60 mm POP insulation be done, polyethylene insulation done. Overheat transfer coefficient for this insulation is 0.308. So agitator motor, so what is the load of the agitator, how much heat input by the agitator, everything is calculated here. You can see here, we have done the calculation for that. Inside temperature 4 degree, room temperature 35 degree, and mixed product cooling is 1 degree centigrade per hour. Assuming this. The UVA delta T is standard overheat transfer coefficient. Area of the tank is a 3.1 for the periphery. Then this is the top and bottom area, and that multiplied by the temperature, the temperature difference, room temperature minus tank temperature, and again it is 0.81 is a motor load. So 0.1 into 1 kilowatt is considered the heat load of the motor, and this is the product cooling load is considered. And if we get 1.75 kilojoule per second, then 1.75 kilowatt is load. So here it is only we have to consider heat gain from the outside by the outer atmosphere, plus the heating load of the agitator by stirring, and the product cooling something is required 1 degree per hour. Now part one of the making the ice cream from this liquid mix. So it is a partial freezing, part one. What we do, mixing of the flavor, optimum time for freezing. There are two types of freezer available. One is batch freezer. Small ice cream manufacturer use the batch freezer just like we make the ice cream at home by using the wooden churner. Earlier we used to make it. Now I think it is nobody uses that. So similarly, batch freezer also available where we load the ice cream mix and we churn it for certain time, and then we take out the ice cream. Again, we put the ice cream mix and taken out the ice cream, and generally freezing time required in that 7 minutes. In continuous ice cream freezer, it is continuous process. We feed the mix from the one end and it is coming out. I will show how it works it. And generally maximum holding time from the inlet to outlet is only 24 seconds. It is continuous process. Softy ice cream also we have seen, it is also similar to batch process. In that we put the mix and it requires 3 to 4 minutes to come out partially frozen ice cream. If you take more time, what are difference in the process? Now, what are advantage, disadvantage? I will not go in much detail, but as a refrigeration engineer, I will explain to you that if we take more freezing time, the ice crystal will be bigger and bigger. And that is the defect in the ice cream. Because slow freezing gives the bigger crystal and it gives the mouth feeling of the ice, not ice cream. The larger crystal is a defect in the ice cream, so fast freezing is recommended and desirable. What takes place in the freezer? A portion of water is got frozen. Water is frozen into the pure ice crystal, and as the water crystal frozen and make up the ice crystal, the air will be trapped between the ice crystal. And continuous charging reduces the air cell into very small size. Because the ice crystal is smaller, so air will be trapped also in smaller size. It gives smooth texture to us. How it works? This is a mix what we prepared earlier from the aging wet that will be taken here. After put in the color and flavor, pump will suck it, and it will suck the air also from the atmosphere. The mix and air both will discharge in continuous freezer to the freezing cylinder. This freezing cylinder is similar to churner, and it has got jacketed. It has got jacket with the refrigeration system. It may be flooded system. It may be direct expansion system, and the temperature of that jacket is maintained minus 25 degree, minus 30 degrees centigrade, and this ice cream mix is going on the surface of the inside of the cylinder and getting frozen. It is scraped at the same time, and partial frozen ice cream coming out from this outlet. This is the process of the ice cream mix in the freezer. Similarly, this is modern or the bigger capacity automatic plant. The ice cream mix has been measured by the flow meter. Then through the pressure transmitter, we are feeding the compressor, filter compressor from the HEPA filter, and added in the measured quantity. Whatever with the now you decide, you must be knowing that, friend. The density of ice cream is very low. It is not 1. Is it 0.55 or something? So when density decreases, that means volume increase. So the volume has been increased by putting the air inside. And so ice cream contains generally 100% air in that. So liquid is remaining portion 450 or 500. 500 ml is a liquid and 500 ml is the air. Then we say it is 100% overrun. So this compressor has been put in the mix, and it is going to freezing cylinder. Again, the discharge pump also taking ice cream on the cylinder and putting to the filling system. So in the freezer, how to calculate refrigeration? Because we are the refrigeration engineer, and we have to know how to calculate load, refrigeration load. There are 2 types of load. One is sensible load, and second is a latent heat load. And sensible heat load also, there are 2 types. Because specific heat of the mix is changing from above freezing and below freezing. That we should know. Then when the specific heat of the water is something and specific heat of the ice is not the same as the water, but it is much lower. Same thing here happen. The specific heat of ice cream mix is something that is we already discussed 3 point something, 3.65, 3.8 something, and of the ice cream that is below freezing is quite low. So we require to calculate what's the type of load here, what is the specific of that, it below freezing, specific of above freezing, and then this is product latent heat load. This is product latent. How much portion of the ice cream is frozen water is frozen is to be measured, and accordingly that load is coming here. So there are three loads. One is a product cooling from the entering temperature, freezing temperature, then product solidifying load, that is freezing, and third is product cooling after freezing load, that is this load. Now see this chart. The freezing point freezing should start here at the point of minus 2.47 degrees centigrade of the ice cream. That is zero water is converted in the ice cream, ice. When the temperature is lower, minus 2.47 to 2.75, that only 10% water is frozen, 90% remain. Friends, why it is so? As this is a virtual seminar, otherwise we can discuss much detail on, because when the water is frozen, sugar quantities increase in the remaining portion, which depress the freezing point. When 10% water is frozen, the 90% water is lost, left out, but whatever sugar you added, 15-16% remains at 90%. So there is a depression of the freezing point. And that's why this freezing point is changing continuously. It is just like transient heat transfer. The freezing point is changing of the ice cream continuously. And I can say that it is difficult to freeze 100% ice cream. Even we say with minus 80%, it is mostly frozen. So freezing point is reducing, and how is it reduced? It said if our outlet temperature of the ice cream minus 5 degrees centigrade, only 45 to 50% water is frozen, which I was telling to you. So when we calculate the refrigerant load for the continuous ice cream freezer, first we should know the property of the ice cream mix and what is outlet temperature. On the basis of outlet temperature, we can say how much quantity of the water frozen, and we can calculate the latent heat load on the basis of this percentage only. Even at 90%, you can see it. Only at minus 30 degrees, it is only 90% frozen, not 100% frozen. Generally, we say the ice cream is frozen at minus 18 degrees and stored at minus 18 degrees centigrade. This ice cream core temperature is minus 18 degrees. It has been stored at minus 23 degree temperature, so we can maintain the core temperature minus 18 degree temperature. So not 100% frozen. Then only we can do scooping. To calculate a refrigerant load for the continuous ice cream freezer is somewhat complicated. How? First is that we have seen the edging weight. Here the heat gain by the cylinder is to be required to calculate. Again, sensible load before freezing required to calculate. Latent heat load of freezing required to calculate. Again, sensible cooling load after freezing required to be calculated. Plus, what is the power required for scraping of the ice cream? That is also required. And mix it transfer from the pump to the freezing cylinder. There is a pipeline, everything. What is heat gained by the pipeline, by the heat added by the pump, air, everything is required calculated. So it's a very complicated process. But what is required? I try to explain. We require generally 2.5 kilojoule per second for the 100 liter, or say 55 kg per hour the ice cream, if it is partially frozen, is minus 5 degrees centigrade. This is practically we have studied, and we found that this is a refrigerant minimum requirement. Otherwise, the refrigerant load calculation requires product load, desktop power load, pump power load, and heat gain, and it requires detailed calculation for that. If somebody interested to see the refrigerant system, it is simple vapor compression system. It is nothing new in that. System is the same. This is a compressor. This is a compressor. From the compressor, gas is going to condenser. Condenser to this end sort of valve, then filter, solid valve, indicator, liquid indicator, again valve, expansion valve. You can say and go into the freezing cylinder, and the liquid is evaporated and taken back to compressor. And there's one connection is given to the hot gas from condenser to the freezing cylinder. In case ice cream is more frozen and not coming out or getting jam, so we can supply the hot gas, and by hot gas we can heat the ice cream and we can take out it. That is a simple refrigeration system, my dear friend. How it looks is a flooded system that has been shown here. This is a flooded system where the flooded, this is the the refrigerant is put in the cylinder jacket and it is coming out. Generally in ammonia, we use a flooded system. So this, it will go to the centralized ammonia system. Liquid is coming from the centralized ammonia system here. It is coming here, and this is the, you can say, accumulator or the liquid and gas separator, and liquid is feed and going to here again. And again, suction taken to the ammonia plant, the centralized plant. This is again the cold compressor. There is nothing, it is same system, but there is some requirements of cold compressor when it is going for low temperature and when the discharge is high. It requires some the cooling of the cold compressor. It requires heat injection, liquid injection system, and that is shown here. This is how it looks in the isometric. How looks the freezer? This is photo of the freezer. When we saw the factory visit, that time you can see this type of equipment. This is the freezer where this is the ice cream mix pump. It is taking the liquid from here, putting inside the freezing cylinder. Ice cream after partial fusion coming out and again going to the second pump, that is ice cream outlet pump, and going to the filling machine. Now we are coming to part second. That is how to convert a partially frozen ice cream suitable for distribution for the retail marketing. Because here the only water 40 to 50% is frozen, and remaining water required to be frozen before dispatch to the retailer and make suitable for the consumer. As I explained to you earlier, the fast freezing is essential for the making the ice cream. If you do a slow freezing, then the ice crystal will be bigger size and it will not give a good mouth filling, and it looks like that we are eating the ice, not the ice cream. So here what you have to consider, the fast cooling is done by the air blast freezer. In the air blast freezer, the blast freezing is recommended for rapid fall in the temperature. How it looks. This is a simple air blast freezer where you can see that there is the air cooling unit that will give the very cold air, minus 25, minus 30 degree, and ice cream is kept in the trolley here. And this is one side ice cream entering and second side ice cream taking out, and this requires retention time of the ice cream. It is not a continuous process. It requires certain retention time. It retention time depends upon hardening. That retention time depends upon the type of the packet, size of the packet, type of the shape of the packet, and it depends upon that. So it may be 1 hour, it may be 4 hours, 5 hours also. Let me calculate how to do the cooling load, refrigeration load for the air blast freezer. It is again the simple process, but require proper judgment of the old data. As I explained to you earlier, the ice cream contains 35% to 40% of the solid and remaining is water. In this case, I assume it contains 61% of the water, remaining is a total, so 39% total solid. Total solid means it contains fat, solid not fat, sugar, stabilizer, emulsifier. That is 35 to 40% generally in the ice cream. We can assume the ice cream has a 100% overrun. Why it assume? Because in refrigeration load, we are concerned with not a volume of the ice cream, but we are concerned with the mass of the ice cream. And to calculate that mass, we should know what is the overrun of the ice cream. Entering temperature of ice cream is minus 5 degrees centigrade. We consume that, we assume that at the minus 5 degrees centigrade, 45% water is frozen, remaining is required to be frozen. And ice cream outlet temperature is minus 80 degrees centigrade. And here we consider that it is more or less 100% water is frozen. It is theoretical, practically it is not. And accordingly, this is calculated for 1000 liters of the ice cream. How much refrigerant load is 1000 liters? This is the density of the ice cream. This is the specific of heat below freezing. And this is the latent heat of the water. It is coming 1,12,392 kilogram for 1000 liter, not 1000 kg, my dear friend. So this is the thing. This is require the refrigerant load to weigh 55. No. Okay. Sorry, my this 1000 kg, my dear friend. 55 is a water content left out. 55 is a water content left out. Unfrozen water content. This 1000 kg, the mass has been considered, not a volume is considered. So 55% is the water content left out, unfrozen. That is thing. This is a specific heat, and this is a thing. So you get this one. This is a total. This is latent heat. That's not. Sorry. Again, I have mistake. I done mistake. This is 1000 kg is there. This is a unfrozen water content. The water content, and this is latent heat of the water. This is the total solid. That is water content in the ice cream. This is unfrozen water content of that. And that is what. How in continuous, if you want to freezing continuously, then we require such type of equipment, not the spiral belt freezer. Here, what we do, we put the ice cream content here at one point, it is rotating, and whatever time is required is to be given in the belt, and it is coming out. It just looks like continuous process, but it's not like that. It requires to give retention time. The length of the belt is to be calculated on the basis of the retention time required, and the speed is to be accommodated accordingly. It looks like that, the box. The belt is moving here. It looks like that is the actual photograph of the equipment. Difficult to explain this total PI diagram, but it is certainly when we go in this, there is some complication, and the complex diagram will be there. This is diagram of two-stage compressor system required for the spiral freezer, where the interchange cooler is there, everything is there. I think it is not difficult. It is difficult for me to explain in this short time. It requires hours together to explain each and every component. But I can explain, say, this is an interchange cooling system, two-stage compressor system. After first stage compression, the gas has been cooled in this equipment, and again it's been pumped to second stage for the further compressing. The two-stage compressor system. This is brine system, where I explained to you brine cooling is to be done. The reference system for the brine cooling, it is simple, single stage system. Only here we try to put two expansion valves because there are two inlet in the chiller. This is automatic stick line, where brine has been circulated in this, and this convey is moving and extracting and making the chocobar or any product. How it looks, you can see. The reference system for that brine cooling, again to two-stage compression system, but here instead of evaporator is a chiller, saline chiller, tube and cell chiller. How it looks a plant of the ice cream industry. It is not this screw compressor. You can see the plant. It is a very big size plant. It's a complete plant of that. This is a complete plant of the ice cream industry, producing 1 lakh liter per day ice cream. This plant is we install in Nagpur. Now, These are the condenser, my dear friend. It's a PHE type condenser. This is the receiver. This is the process flow diagram for complete ice cream project, where the hardener is there, cold room is there, chill water tank is there, ice cream freezer, everything. So this is complete refrigeration system for the ice cream project. These are the compressor. These are the all are compressor. These are compressor. These are condenser. You can see from condenser the liquid refrigerant is going to receiver. There is the air purger to remove the non-condensable gases, whatever enter inside the system due to leakage. There is an intercooler for subcooling of liquid. Means whatever we learned that all the processes are done here, and it will the subcool liquid going to the evaporator. These are the evaporator. These are the evaporator. These are the also evaporator. You can consider here all are evaporator. Many times liquid nitrogen also for the cooling or the freezing of the ice cream. There's a system for that. Thanks. If you have question, you are free to raise a question as per the procedure laid down by the history Professor Shukla, and we'll discuss that.
Oh, thank you, sir. Thank you, sir. It's a really wonderful session. Harshal bhai, can we take question now or after video virtual visit?
Video pachi, we take after video, I think so that they can get
Okay.
Yeah,
very
yeah.
practical.
Okay.
They can see the ice cream, making of ice cream.
Yeah. Okay. Okay. Fine. Okay. So I request everyone to see the virtual way to visit Synergy Agrotech through the video mode, please.
I think everybody can see it.
Actually, screen is visible, but video yet not started. It shows like that.
It is not started.
No, on screen only 6 videos have been placed, but it doesn't.
Just 1 minute. Okay, software share. Share screen.
Yes, now screen is visible.
Video is visible.
Not yet started. It shows.
It is visible now.
No, Harshal. No, Harshal.
It is visible. Adi, it is visible now.
No, Harshal bhai. Only your screen is visible. If you can start in VLC media player or yeah.
1 minute. What do you say?
If you can start in media player, open the media player and run that video in media player, so it would be possibly work. In between, I raise the question to audience so we can have the interaction. Yeah.
Okay, no problem.
Yeah. So I request, first of all, I am thankful to Dilip Sarda sir to take this session much energetically. And sir, in last 1 hour, none of the audience has moved. We retain with the full strength. Thank you, sir. And it's really a great exposure to learn from the person having more than 45 years of experience in this field. And today there are not the students from Ahmedabad only, but there are the students from Baroda, Surat, long way from Kolkata also. So I request everyone to raise your question so I can ask to sir. If you have any question, actually I have requested sir to take the cold chain session which we used to take him, but sir is always eager to deliver new topic to the student and the industry people. So I request audience to please type down your question regarding the refrigeration, regarding the cold chain, regarding the ice cream. Sir will answer. Please type down your question in chat box. Rajendra bhai, chat box is open for all.
Yes, Hardik bhai.
Yes. Okay, done. So I request students. Yeah. Okay. Harshal bhai, it is okay.
वीडियो चालू करें Adi bhai, can you see the video?
Yes, done. Perfectly okay. Harshal bhai, perfectly okay.
Okay. Okay, this is the automatic candy machine, ice cream machine. This is the internal gear pump that what I showed you in the photo, the presentation. So this is in this screen you can see the suction pressure, discharge pressure, and the speed of the compressor, which is running 100%. You can see the temperature of the ice cream also. This is mixing of the fruit. There are two types of fruit in there. One is dry fruit and one is jelly. This is how they are mixing in the ice cream. Okay, we'll see the second how to make a chocobar. I think everybody can see it.
Yes, perfect, Harshal bhai. Very perfect.
This is filling of the ice cream.
This filling of ice cream. Now stick will be inserted when the semi-freeze happen.
How the stick can be inserted? What type of mechanism is there?
Yeah. Other, now there will be extraction and chocolate dipping.
Using this candy in the brine tank, it is to be extracted, taken out. You can see that it has been dipped in the chocolate.
This is a touch screen panel. You can control it by that touch screen. There is no button in this. After this, the candy will be taken out and it goes to the packing. This is how the packing will take place.
Here you can see the print, the print untouched totally. Nobody has touched the product till it is packing from the filling.
Now we'll see how the mango dolly is making. First, the juice will get filled. So this you show that it is for the juice is getting filling. Now this is a must that part of that. That the surface get freeze, the bottom we vacuumize it, we remove the core of it, and we put the ice cream inside it. This is how the vacuum takes place. So we remove the core of it, and in the core we fill the ice cream. Now stick will get inserted. As it becomes semi-freeze, then stick will get inserted so that it can hold the stick. Now we put the cap of it. Juice cap. Now it gets extracted. Now same thing there, it gets packing. This is a refrigeration system. Double stage compressor. And this is brine piping. Now we see the tricolor, how the tricolor candy is making. First halfly we fill the first filler, first color. Then second. And the stick will be inserted. And this is extracted, and in this there will be half dipping of chocolate, so you'll see the three color. See, you can see the three color now. And then same thing, it goes to the packing. Okay, that's all. Thank you very much. If anybody has any questions?
Yes, Harshal bhai, wonderful. It's a really wonderful, and really we feel that we are in at Synergy Agrotech, but we miss the physical ice cream.
Okay. Have you enjoyed ice cream now?
Yes, sir. Sir, all the time, I tell you the students and faculties who joined across India from India, sir. I just tell you that every time, at least once in a month, there is a industrial visit at Synergy Agrotech of different institute and even from Baroda as well. And all the time, students and faculty get the opportunity to eat at least 2 ice creams at Synergy Agrotech.
Test ice cream. I say not eat ice cream, test ice cream.
And all the time different flavors, sir. So sometimes it's a demand that yes, we are ready to visit Synergy for ice cream. And thanks a lot, sir. Now there is a few questions from audience side.
Yeah.
Harshal, can I read the question?
One minute. One is that at the time of extraction of candy, it was extracted so easily without a break. So is there any liquid you add on the surface of mold or what? After dipping the chocolate part, solidify with a second. How? What is the room temperature maintained where the candies are made up?
At the time of extraction the candy, it was extracted without a break. Yeah. Here we put a hot water, you can say. The mold is deep. Mold has been deep in the hot water. Hot water is outside the mold. If you see that the mold is at lower level, and there is a one extractor which is trying to take out the candy from that. It is just like we are doing in the home. Similarly way, but it is automatic here. And temperature of that hot water is 29-30 degree temperature only.
Okay.
And easily without a break. So is it easy to you don't okay. After dipping the chocolate part, solidify it within the second. Yeah, yes, because the traveling time is being adjusted from the dipping to the release in such a way that it will get solidified, because the temperature of the ice cream inside the chocolate is minus 18 degree, 20 degree centigrade, minus 18 degree centigrade. It is equalized and gets solidified. What is the room temperature? It is maintained generally same room temperature. Nobody is doing the air conditioning. We recommend the air conditioning at 26, 27 degree temperature, but most of the plants we have seen, nobody is doing the air conditioning it is 30-35 degree temperature only. How can we move towards using the green energy for the entire process? And is it possible to completely make this entire process? Yes, you can do, but you require a very big solar plant, solar power plant. That is nothing, because I have seen many articles and a lot of, I think there's a seminar by the Astra Pune chapter on a similar plan. But it requires wind energy, it requires the power, and power has to be produced by the renewable energy, then only we can do something. Then for which company do they make the ice cream? For which company do they make ice cream? I'm not, but we are supplying the plant to everybody, and we have got more than 1,500 plant. And whatever the machine you have seen, this stick line, that also we have installed more than 15 number in India and exported also. Try in VLC media player, how much was it? Okay. Okay. So only there is the audio and no video. Okay. How can we move toward the using the green energy? IQ. So what about the cleaning of tube? The physics cylinder or which tube?
I think so. It is not done. Which tube is not clear?
Then what tube you are saying that is not clear? Otherwise, I can reply.
I think so. This is not
low calorie ice cream. Oh, that is a nutrition and we are the engineer, my dear friend.
We don't know about that. Sorry.
What is the amount of electricity bill per month? It depends on the production, my dear friend. How much ice cream you want to manufacture, that we can decide, and accordingly there is a production. And what product you want to make.
How to simulate solidification of water in a mixture of fats and sugar?
How to stimulate solidification of the water in a mixture of the fat and sugar? Simulate.
Okay. How to simulate solidification water in a mixture of fat and sugar? Means when you mixing, when you do the pasteurization.
Yeah. When we take all the ingredients, we are eating the fat and everything, so it will get an homogenizer doing the mixing of that. Homogenizer, I already, if you see the slide of homogenizer, it has been mentioned, it is helping in the mixing and evenly distribute all the ingredients in the liquid, in the water or the water base. Summer B.
Winter monsoon में 1 लाख लीटर था.
No, there is a yeah, it is possible, but there is no demand. It depends on demand, like my dear friend. How many ice cream can be made with 1 liter? It may be 2 liter, you can say. For 1 liter syrup, you can make 2 liter of ice cream, considering the whole 100% oral. Any more?
Anybody wants to ask any question? I think this is enough question that has been asked. Also, sir, I tell you that in today's program, there are 4 past presidents of ISRO Ahmedabad chapter who were in queue only. Couldn't join.
I thank you also, my friend, old friend. I thank you again, sir.
Yeah, so that was the success of this session. And sir, absolutely, in a wonderful way, you have covered the points and also solved all the queries raised by the students and the members who attended. So I am thankful to you on behalf of all the students team and the faculty members who have attended. Thank you, sir. Thank you, Harshal bhai. Thank you, sir.
Thank you. Thank you. Thank you.
Thank you, sir. Thank you, Harshal bhai.
Thank you. I request all to leave the session. Thank you.